Hi everyone, as promised in this video we're going to go over some examples of how we might use the fundamental trig identities. So one thing that we said that the trig identities would help us to do is to simplify complicated trig expressions. So let's go ahead and do that. Sometimes it's a little ambiguous what it means to simplify, but usually what we're trying to do is condense the expression, maybe make it a product of things, get as few trig functions as possible. So the first thing you might notice about this expression is that there's a sign in each term. So my first step here is going to be to factor out that sign. Oops. So when I pull sine out of the first term, I'm left with cosine squared. When I pull it out of the second, I'm left with 1. This should look familiar to you. It looks pretty similar to our Pythagorean identity. So remember, from the Pythagorean identities, sometimes we see it in the form 1 minus cosine squared equals sine squared. So that's pretty close to this. If I pull out a -1, then this becomes negative cosine squared, and this becomes 1. So my first step was factor. My second step was pull out -1. Now I'm just going to rearrange that. So I haven't used any identities yet. I've just factored, really. But now I know that 1 minus cosine squared, this is sine squared due to the Pythagorean identity. So I end up with 1 minus sine x times sine squared x, which is sine cubed x, due to the Pythagorean identity. And I want you to get into the habit of writing the reasons next to each step that you've accomplished. So let's do another example. One thing that we said that the trig identities would help us to do is evaluate trig functions. So I know that sine of x is 1/2 and cosine of x equals √3/2. In the last unit, we were able to find the other trig functions by drawing a triangle. In this unit, we're going to be able to do this without the picture. We'll be able to do it using the identities. So let's start out with this fact. Sine of x equals 1/2. Then there's a quick way that I could get cosecant of x. How do we do that? Well, take a minute and think about it. Sine and cosecant are related, but how? They're related as reciprocals. Remember from last time that sine is 1 over cosecant, so I can find cosecant by taking the reciprocal of sine, which means cosecant of x will be 2. On the other hand, because cosine of x equals √3/2, its reciprocal is secant, and so secant of x is going to be 2 over √3. So here I use the reciprocal identities. Now to get tangent, I can use the quotient identity. Tangent is sine over cosine. So sine is 1/2. Cosine is √3/2. This simplifies to 1 over √3. So this is the quotient identity. And to get cotan, I could either use the quotient identity, the other quotient identity, and do cosine over sine, or I could just use the fact that tan and cotan are reciprocals and flip the tangent. And I think that's a little easier. So cotan is √3. So those are our first two examples. Let's move on to the next. Another simplify. So here I want to simplify sine of t plus cotan of t times cosine of t. And again, my goal when I'm simplifying is to limit the number of different trig functions that I use. So sine and cosine are usually okay. Cotan is a little bit confusing, so maybe I want to convert the cotan of t to sines and cosines. And I can do that by using the quotient identity. So we have sine of t plus cosine of t over sine of t. That's replacing the cotan times cosine of t. And this is by the quotient identity. Okay, so now this is still not very simple. What I'm going to do is get a common denominator, which means I have to multiply this term by 1 in a clever way. The denominator is supposed to be sine, so I'll multiply by sine t over sine t. So I end up with sine squared t, and then this term, the cosine and the cosine multiply, so cosine squared t. That's my numerator, and my denominator is sine of t. So this is by getting a common denominator. And now, what's sine squared plus cosine squared? That's equal to 1 by the Pythagorean identity. So my final answer is 1 over sine t. Well, I guess that's not my final answer, because what's 1 over sine t? That's the same as cosecant of t by the reciprocal. So first, I use Pythagorean identity, and then I use the reciprocal identity. In the next example, I'm asking you to factor this expression, sine to the fourth minus cosine to the fourth squared. So fourth powers are also perfect squares. This is a difference of squares. So remember, if I have u squared minus v squared, this factors as u plus v times u minus v. So sine to the fourth is sine squared squared. So my u is sine squared x, and my v is cosine squared x, and that will give me this expression. So the way that this will factor is sine squared x plus cosine squared x times sine squared x minus cosine squared x. And what do you see that simplifies here? Sine squared plus cosine squared is 1. And that's Pythagorean identity again. So that's a really, really important identity. Comes up a lot. But I can continue to factor this expression because this also looks like u squared and v squared, where in this case u is sine and v is cosine. So this further factors as sine x plus cosine x times sine x minus cosine x. And that will be my final answer. If I really wanted to just have sines or cosines, I could use the cofunction identities, but usually we don't do that. I think having just x inside of sine or cosine is easier than having pi over 2 minus x. So this is simplified enough. Okay, and we have one more page of examples. Here they are. All right, so this first one, really simple. We've actually already used it plenty of times. This is going to be cosine squared u, and that just follows from Pythagorean again, because the Pythagorean identity says cosine squared plus sine squared equals 1. So this is the same, where I just bring the sine squared over. And finally, I want to square this expression and simplify it. So I'm going to need to FOIL, because what I'm really doing is cosine u plus sine u times cosine u plus sine u. So I do first, gives me cosine squared u. Outer gives me cosine u times sine u. Inner gives me another cosine u times sine u. I can change the order because multiplication order doesn't matter. And last gives me sine squared u. So now combining these together, I have a cosine squared and a sine squared. Cosine squared plus sine squared is 1. So those two terms combine and give me 1. These two are the same, so I can combine like terms, and I get 2 cosine u sine u. So continue to practice with these types of examples. The types of simplifying that we're going to do are just going to get more and more complicated, but as you get used to using these identities in cases where you're not using many identities at the same time, you'll get better and better and better at this. We'll do plenty of practice during class. See you soon.